All right, this week we started learning about the mole. And in this lesson, we're going to be doing 3 of the main types of problems that we're going to see. So by the end of this week, we should be able to do problems where we're converting between moles and particles. We should be able to find the molar mass of molecules. So that'll be something that becomes very important. And then the last thing we should be able to do is be able to convert between mass and moles. All right, so the first thing we need in order to do this is to make our mole roadmap. So draw one of these in your notebook. And in the middle of our mole roadmap, we're going to have the mole. We'll put a little box around it. The mole. And the mole allows us to do a lot of things. It allows us to convert into particles. So I'll put particles over here. Another thing it allows us to do is convert into mass. So I'll put mass over here. So the first question that we have, or that we need to be able to do, is be able to convert between moles and particles. So when we go from moles to particles, all we have to do when we're doing this is multiply by Avogadro's number. So if we start with moles and we want to go to particles, we multiply by 6.02 times 10 to the 23rd, and we get particles. If we're starting with particles and we want to get to moles, we got to do the exact opposite. So we will need to divide by 6.02 times 10 to the 23rd. So let's see what this looks like in action. So there are 20 practice problems that you guys are expected to do. I've chosen a couple today that we'll be doing on the video. So our first one will be this one, number 2. Calculate the number of molecules in 11.5 moles of water. So we're starting at moles. We want to get to particles. We want to get to molecules. Molecules is a type of particle. So we start with our 11.5. We just multiply now by 6.02 times 10 to the 23rd. And the answer we get should be, this should equal about let me make sure this is on the screen here, 6.92 times 10 to the 24 molecules. So that's one example. Let's say we wanted to go the other way. So in number 7, it says calculate the moles of water that you have, or calculate the moles of water if you have 1.25 times 10 to the 25 molecules of water. So this one we're starting at particles and we're going to moles. So in this case, we have 1.25 times 10 to the 25. We're going to be dividing. I'm going to put these in parentheses. You might want to do that on your calculator too. And we're dividing by Avogadro's number. So 6.02 times 10 to the 23rd. And that's going to equal, you do all that in your calculator, it should give you equals about 20.76 moles of water. So that's how we would do problems converting between moles and particles and moles. All right, so if we had a question where we had to find the molar mass of a molecule, I'll show you how we would do that now. We would need to get a periodic table. And if you take a look, all of these lower numbers here, let's zoom in really close so you can see some of these. All of these numbers here near the bottom, so for oxygen it'd be 15.9994, or for fluorine it'd be 18.998, or for carbon it would be 12.0102. Those are our atomic masses. And we use our atomic masses to calculate our molar mass. So, if I had a question, let's zoom out just a tidbit. If I had a question like question number 8, find the molar mass of aluminum. Aluminum is an element, so we could just look straight on the periodic table. We can see it right here. We got aluminum, 26.98. We could just round to the nearest hundredth. 26.98. And I'm going to say the units are very important here. It would be grams per mole. So that is as easy as it is to find the molar mass of just a single element. It does get a little bit harder if you want to find the molar mass of a compound. So let's do a practice question like that. Number 9 is find the molar mass of H2O. So this would be finding the molar mass of water. So we need to take a look at each element in this compound and add up their masses together. So if we take a look, hydrogen, if you round it to the nearest hundredth, would be 1.01. So we're going to say 1.01 for hydrogen. We'll put H here. So H is equal to 1.01. And if you take a look, we have 2 hydrogen there. So we got to multiply it by 2 because we got 2 of them. So the mass from a hydrogen will be 2.02. Now we got to take a look at the mass from oxygen. Whoops. From oxygen there. And we only got 1 oxygen. So let's move over to this side. And if you round oxygen's mass, it's 16. So let's write that in here. 16. And we only have 1, so we can multiply it by 1. Equals 16. And then we just have to add those together. So if you add those 2 numbers together, the molar mass of our water would be 18.02 grams per mole. All right, let's do another one just for some good practice. What if I wanted to find the molar mass of oxygen, a molecule of oxygen? So this is oxygen, but we got 2 of them. So remember, we just found the molar mass of 1 oxygen. 1 oxygen was 16. In this case, we have 2 of them, so we have to multiply by 2. And we should get 32 grams per mole. And that's our answer because there's no other elements there. So the molar mass of O2 is 32 grams per mole. So that's how we are going to use our periodic table to find the molar mass of our molecules and elements. Now, the last thing we have to be able to do is convert between mass and moles. So I'll show you how to do that now. We have our roadmap. Let's zoom out again so we have the whole thing. We have our roadmap. And if we're given moles and we want to find mass, what we have to do is we will need to multiply by our molar mass. If we have the mass and we want to find how many moles that is, all we have to do is divide by the molar mass. And the reason this works is because all compounds, they have a different molar mass. So they're going to have different masses for how many. Let me say that again. All compounds have different masses. So it might look like you have a different amount. You'll have a different mass. It'll equal a different amount of moles depending on what compound you have. So it's not always going to be the same number like this one. Depending on the compound, you're going to have a different molar mass that you're going to have to multiply or divide by. So let's do some examples of that right now. All right, so question number 14. Determine the mass of 3.5 moles of aluminum. So we know the moles and we want to find the mass. So what we have to do is multiply by the molar mass. Good thing we already found it in question number 8. So all we got to do is we have to multiply all we got to do is multiply. Let me get another paper over here. These two numbers together. So it would be it would be 3.57 moles of aluminum times 26.98 grams per mole, and that should give us the amount of grams should be, let me plug that in a calculator real quick. Should be about 96.3 grams. So that's how we're going to go from moles of aluminum to mass of aluminum. Let's do a few more examples like this. I need to get another paper real quick. All right, so if we had a question like question 15, determine the mass of 5 moles of H2O. Luckily, we already found the molar mass of H2O here. So again, we're going to be doing the same thing. We got our moles, 5 moles. We're going to multiply by our molar mass, 18.02 grams per mole. And that'll give us our mass. So our mass in this case would equal 90.1 grams of water. All right, let's do one last example problem and we'll call it good for the video. What if I had the grams, let's say I had 40 grams of O2, but I wanted to know how many moles that is. So now I have my mass. I need to figure out my moles. And again, I figured this one out already. We got the molar mass right here. So now we just got to write this down. We have 40 grams of oxygen. We need to divide it by 32 grams per mole. And it should be 1.25 moles of oxygen. All right, I'm hoping this helps. I want to make sure everyone has this diagram in their notebook because this will help out a lot, because I know some of us struggle with knowing what to do with our conversions. So make sure this is in your notebook.